Okay, good morning. Welcome to
Awesome Math number 4.
Awesome Math number 4. Today we were learning about divisors and factors. Yesterday we talked about multiples, right?
Yeah.
So we said 15 is 3 times 5. That meant 15 was a multiple of 3.
Yeah.
Okay. And today we sort of talked about the opposite thing. We would say this also means 3 is a divisor. Or sometimes we also use the word factor, a divisor or factor of 15. So 15 is a multiple of 3 because it's 3 times some integer.
Yeah.
And 3 is a divisor of 15, or 3 is a factor of 15 because 3 times some integer equals 15. Okay, so they're very similar concepts. Yeah. And we learned a little bit about how to find divisors.
Yeah.
Okay, so why don't you pick a number and we'll find the divisors of that number.
Let's maybe 25.
25. Oh, an interesting choice. Okay, what are the divisors of 25?
Well, there's 1, 25, it's not divisible by 2, and not by 3, not by 4, now it's just 5 and then 5, so there's only 3.
Ooh, interesting.
Because 25 is a square, it's 5 times 5.
Yeah, so what happened when you had a square?
There's two, the same number on both sides, but you can only count one.
Okay.
And squares are the only ones to have that.
Yeah, did you know that before, or did you just discover that?
I think I knew that before.
Oh, you knew it before, okay. Well, that's good. Pick another number.
Maybe 38.
Ooh, this could be an interesting one. 38.
1, 38, then 2, 19, and then not by 3, by 4, well, no, not by 4, not by 5, is it by 6? Well, no, because 6 times 5 is 30, and then, can I get that?
Yeah.
And 7, because 7 times 5 is 35 now. 8 times 5 is 40, you go down to 32.
Yeah.
I don't think there might not be any more.
Oh, that's it. That's it. So that was an interesting one. It only had 4 divisors.
Yeah.
So one interesting thing, once you found the divisors, is we can count them. And you talked about something that's actually pretty interesting. Perfect squares have an odd number of divisors.
Yeah.
And non-perfect squares have an even number of divisors. I'll show you something else that's kind of neat. We're going to look at 2 numbers. 6 and 28. Okay, find the divisors of 6.
1, 6, 2, 3.
Okay. What about 28?
Well, it's 1, 28, and 2, then it's 2, 14, and then it's not by 3, by 4, it's 4 times 7, and then I think that's it.
Okay, because 5 doesn't go in and 6 doesn't go in.
And then there's 7.
Okay. So now, the book talked about something called a proper divisor, and that was a divisor that wasn't equal to the same number.
Yeah.
Okay, so add up the proper divisors of 6. What do they add up to?
They add up to 6.
1 plus 2 plus 3 is?
6.
6. Add up the proper divisors of 28.
equals 2 is 3 plus 4 is 7. 14. 7 plus 14 is 21 plus 27 is 28. So it seems like all of the proper divisors, all the proper divisors add up to the non-proper divisor.
Well, I picked these numbers because they're special.
But
Numbers where that happens are called perfect numbers. They have a special name. 6 is a perfect number. 28 is a perfect number.
perfect.
Perfect. And so you can try if you want to try to find more.
Cool.
And people have done that. So it's neat. There's some neat questions about divisors. And we'll learn more as the book goes on. Alright? Alright, good job this morning. So now we know what multiples are, divisors, and factors.
Yeah.
Because factors are the same as
Divisors.
factors are the same as divisors. Okay, good job this morning.